This is a pretty tough practice SAT problem. Definitely takes a little bit of time to get through this one. But they present us with these two equations, and they say in that given pair of equations, A and B are constants. The graph of the pair of equations in the xy plane is a pair of perpendicular lines. Which of the following pairs of equations also represents a pair of perpendicular lines? So what I realized right away is that in order for lines to be perpendicular to one another, they have to have slopes that are opposite reciprocals. I can find the slope of this first line by solving the equation for y and looking at the coefficient of x. So my first step to solve this equation for y would be to take a minus 5x from both sides, and then I would divide both sides by 7. The number in front of x is going to be the minus 5 divided by 7. So the slope of this top line is negative 5/7. I know the slope of this second line, in order for it to be perpendicular to the first, has to be the reciprocal, so the fraction gets flipped, and also the opposite, so the number gets made positive. And so what that tells me is that A would have to be negative 7, and B would have to be positive 5. Reason why, to find the slope of this line, I would subtract A, and then I would divide by B. So if I have minus A divided by B as the coefficient of x, and I need this to be the answer in order for the lines to be perpendicular, I would need negative negative A to generate positive 7 divided by 5 in that denominator. Okay, now look at the answer options. We're going to have to go through the same sort of sequence with each of them. So what is the slope of this first line? Subtract 10x, divide by 7. You're going to have negative 10 over 7. Do that with this second line. Subtract ax, divide by negative 2b. This would be the slope of that second line. Now put in the value of a and the value of b that we identified back here. This is going to be a positive divided by a negative. A positive divided by a negative is going to be a negative answer, and a negative slope and a negative slope have no chance at being perpendicular to one another. Now if you look at option B, same strategy, subtract 10x from both sides, divide by 7. I do get a slope of negative 10/7, and I guess the one nice thing is that in options A, B, and C, the top equation is the same every time, so you're going to get that slope of negative 10/7 for line 1 each time you check out A, B, or C. Now check out the second line of option B. Subtract AX, divide by 2B. My slope for line 2 would be negative A divided by 2B. Put the value of A that we identified here, put the value of B that we identified here. This is positive 7 over 10. The slope here is positive, whereas the first one was negative. 7 over 10 is the reciprocal of 10 over 7. Option B is the only option that has this set of characteristics. I did the same sort of strategy with the rest of these, option C, option D. You can pause the video and check out that they don't have opposite reciprocal slopes for the combinations of lines in either of those. Tough to do this in a timed situation. Not really a very efficient way to go about this, but that hopefully explains 26.